Hello there. Today we are going to be talking about strings, looking at how to modify them, how to examine them, how to do all kinds of different things with essentially text. That can be in the form of numbers, symbols, letters, and so on. So in our first exercise, we're going to write a function that takes as a parameter a string in the form of a logical expression, so something like 2 greater than 5 or 1 not equal to 5, and return true if the statement is true and false if it's not. So we're going to assume for the case of this that we're only going to be working with 4 operators: equals, not equal, less than, or greater than, and that each value is a single positive digit. If these conditions weren't here, this would be a much trickier problem, but fortunately because of these, it shouldn't be too hard to actually get this going. So let me copy this just so I don't have to reference this slide again and put this in as a comment. So here's what we're going to do. That is very long, so let's space that down. At this point, now that we've done code style, we can try to adhere to some somewhat decent code styling in the form of a logical expression. Return true. All right, there we go. And since we are working with strings now, we're going to need to include one more library, which is the string library, because there's all kinds of stuff that we're going to need from that over these exercises. Now, we're going to write a function and then call it. So our function is going to return a true or false, so it is a Boolean function, and we're going to call it, I guess, evaluate, and it's going to take a string, so string expression. Now I think that should be fine. Okay, and now what do we know about this expression? Well, we know the maximum length of it is going to be 4 characters, because at the very longest, since everything is a single digit, we can only have 1 digit at the end, at the beginning, 1 at the end, and then a symbol in between, which could be at most 2 characters. So we have 3 or 4 characters to work with. And what we note is that the second character always uniquely identifies which operator we're looking at. If the second character is an equal sign, it's the equals. If the second character is exclamation mark, or this, we all have different possibilities. So what we actually can do here is we can make a little switch, and we're going to use it on our expression, specifically the second character. Now, the first character of each expression is the 0th character. That's the first one, which means that number 1 is the second character. So from our second character, we have a couple of cases. One option is equals. One option is exclamation mark. One is lesser than, one is greater than. So exclamation mark, lesser than, or greater than. And just for the case of for some reason we didn't get anything else, we're actually just going to put in return false. This is in the weird case we get an expression that isn't formatted correctly. We'll just say no. Now, just to make sure everything is working correctly, we're going to try doing one of these cases first, and then we'll build up all the other ones after, but these should be fairly short, which is to what we're going to need to do is we're going to need to take our string, which has digits in it, but these are not integers. We need to convert them to integers and then compare them. So in our equals case, we essentially just want to return whether or not the first number and the second number are equal. So we're going to return whether or not the first number, which is an integer, is equal to the second number, which is also an integer. And so the first number is expression 0, and the second number is expression. So in this case, we have 0 is the digit, equals number. So we're looking for 3. And to verify this works, let's try a couple of cases. So we're going to try to see out. Let's try, 5 equals 3, question mark. And then we'll put the result of our evaluation on, I should write it in the proper format. So 5 equals 3. And then we'll try another one that is true. So let's try 3 equals 3. So I should get one of these to be true and one of these to be false. Now let's see what happens. So now here's the thing to note is, again, Boolean values can be either true or false, which means effectively 1 or 0. So 1 means true and 0 means false. But I might want to actually make it clear that I mean true or false and not just these numbers. So we can actually use a little shortcut here. Now, one way to do this is write a whole if statement, and you say if it evaluates to true, then do this, otherwise don't. But there's a shortcut that I'm going to show you right now, and it's to use this little question mark. So the question mark here is effectively saying, okay, let's do an if statement, and the condition for the if statement is right before the question mark. So here it's if I evaluate this and it's true, then we ask that question, and as soon as we have the question, if it's true, then we're going to have a value that comes out of this. In this case, we want to go with true. If it's not the case, then this is going to evaluate to false. Now, I might need parentheses, but let me just see first if this works. No, okay, I need some parentheses, so let's do that. Okay, and we'll copy this actually for the other one as well, just so you can see it in action. 3 equals 3. So what's going on here is instead of just printing out the result of my function, which is giving me true or false, represented as a 0 or a 1, I can actually just use the true or false in an if statement that I construct in the line without having to write a whole if statement out with the word if and then else if and so on. I can just say, here is the thing I want to evaluate. Is it true? If so, the first option. The colon means otherwise, the second option. And there we go. Now, let's do this again, but for the other cases that we have to work with and make sure that they all work. So, unsurprisingly, we can actually just take this little line we've written here and copy it for all of our cases. So copy this, copy this, copy this, and there's only one thing we have to change each time, which is that this should be non-equal, this should be less than, and this should be greater than. Also, we have to adjust these numbers because in the cases that we have the less than or greater than symbols, our expression is a little shorter. It's only got, it has one fewer character. So I need to make sure that this is a 2 now, and this is also a 2. Now, let's test all these out. So we're going to copy this a couple times. One here, one here, one here. We're going to do is 5 less than 3? Is 3 less than 3? Is 5 non-equal to 3? Is 3 non-equal to 3? And is 5 greater than 3? Is 3 greater than 3? And we'll do those exact same things over here. Greater, not, and less. And let's see if everything works out the way we expect. Okay, so 5 is not equal to 3. That's good. 3 is equal to 3. That's good. Is 5 less than 3? That is false. And 3 is also not less than 3. That's false. We should do 1 to make sure that it does return true. So let's do that just in case. Let's make sure that 2 is less than 3. It's always good to make sure that you verify everything is working here. So do we have 2 is less than 3? Yes, so everything is good there. Is 5 not equal to 3? Correct. So we get true. Is 3 not equal to 3? False. It is equal to 3. 5 is greater than 3, so that's true, and 3 is not greater than 3 because they are the same. So there we go. We just had to make a single switch, and we can use the index of the character in the string to pull out the digit we're working with, or in this case, the symbol that we're looking for. And that's it for our first exercise, and we can try out our next one. Okay, let's go to our next exercise, which is write a program that takes a word as input from the user, calculates the number of capital letters in the word, and then what happens if they try to enter a string of multiple words. Let's do the first part first. So we're going to take a word as input from the user and calculate the number of capital letters. Okay, well, so we're going to comment this out for now. Don't need that. So we're going to need to get something from the user. So as usual, we should ask them, please enter a string. We're We're going to need to store it somewhere, so we'll make a string, their input. All right, we got their input. Now, we need to count how many uppercase characters are in there. So we need to look at each character in our string one at a time, which means we can use the fact that we can index different characters in the array to our advantage. Now, I believe we need to calculate the total number. So if we're going to calculate a sum of things, we should have the sum of things, which starts at 0. We're going to increment this over time. We're going to need to loop through all the characters. I is 0, I is less than. Well, now here's the trick. How long is this string? Well, we don't know exactly how long it is until I type it in, but given the input that we have, we can actually access the length of that string. I don't think I need parentheses, but I'll double check. Maybe I do. And let's increment our sum. Let's start out by making sure we can actually count the number of letters in our string, and then we'll go back after. So the number of letters in our string is the sum. We'll start out by making sure we know what we're doing, and then we'll correct things afterwards. So this counts how many letters are in the string, and that's it. Okay, so I think I do need parentheses here. Oh, connection to server is lost. That's not reassuring. Interesting. Maybe I should open my my own VirtualBox and run things there. I guess. Well, first let's try. Actually, we'll save all of this, and we're gonna open a new tab to try it again, just to see if it was just a case of some bad luck, perhaps. There we go. Okay, we can close this over here. Let's enter a string. This sentence has many characters. Number of letters in our string is 4. Well, that doesn't sound quite right, and I think that's because I said I was only going to take a word as input. So clearly, some weird things are happening if I put in a lot of words. Let's just stick with one word. So please enter a word. And let's enter lengthy. Lengthy has 7 characters. Yeah, that sounds about right. So, okay, we can count how many characters are there, but we want to count how many uppercase characters are. So we only want to increment this sum if it is an uppercase character, which means if the character is uppercase, which means we have is upper, and the character we're looking at is the current one, so that's input at index I. Then we'll increment our sum. And now we have the number of uppercase letters in our word. So lengthy has 4 uppercase letters, L-E-N-G, and the other ones are short. And there we go. So all we had to do was use our isUpper function built into C++ and look at the character, at each character one at a time, starting from the first one at index 0 and ending just before the last one. So since the length of our word is 7, the final index of the character is 6. Okay, and I think that's yeah, and we already kind of saw what how things go wrong if we try to use capital, if we use multiple words. So if I say, this sentence has some words, you can see this only actually calculated the number of uppercase characters in the first word, which is not quite what we're looking for. We might want to actually figure out how to do this with the whole thing, but we can we'll see later exactly how to do that. So on to the next exercise. Okay, so now that we have we've completed this exercise, let's go on to the next one. So write a program to get continuous input from the user until they enter the word stop on a new line, then output everything the user typed. And this is where we need to use a little bit of a different technique to actually get their input, where we're going to use getLine instead of the normal arrows that we've been relying on. So let's get some input from the user. We need to output everything they type, so we have to save everything along the way. Now, once again, we can shift this code aside. We're not going to need it. All right, so the only condition in which we want to actually stop is if they write stop. And so until they do, we're going to keep getting their input and adding it to a string. So we're going to have a string that's going to be the combination of all their input. And it's going to start out with nothing. We're going to add to it over time. And then we're also going to have a string that's the current input, which is also going to start out as nothing. And as we get more from the user, we're going to replace our current input with whatever they typed and keep adding that onto our input until we've collected everything. And eventually they're going to say stop. So we want to keep going, and the only time that we are we're going to end this is when the current input says stop. Until then, what's going to happen every time that we get new input is we're going to take our input and we're going to add to it with the string append method the current input. So the first time that we run this, nothing particularly interesting is going to happen because we're adding an empty string to another empty string. But once our current input changes, that's going to make a difference. So to get the input, we're going to need to get line, and we're going to get it from the input and pass it to the current input. And we also should always prompt the user, enter another line. And at the end of this, we can output all of the text. So the whole text is, give it a new line, and then give it the input. All right. All right, that didn't quite do what I wanted it to do. Ah, sorry. While the input's not equal to stop, we want to keep going. All right, so here is the first line, then the second, third, stop. The whole text is, here's the first line, then the second, third. Now this looks ugly, right? We everything is all kind of jammed together. And this is because getLine gets a string, and the string is not going to actually mention the fact that we need to separate these line by line. So when we are appending here, we're actually going to need to append one more thing, which is we want to actually append a new line. So we might need to rearrange this a little bit. Actually, maybe it's okay. So let's append a new line. And a new line is just going to be this special character to go to a new line. So that way we have them all separate. Let's try that again, see how this looks. So this is the first line, then the second, third, and stop. And then the whole text is, this is the first line, and the second, third. And stop doesn't appear notably in the text that was there because we don't want it there. But you could rearrange this easily if you wanted to include stop, for instance. Maybe you use a do while loop instead if you want to change the order of some of these lines, for instance. But this ends up giving us what we are looking for. So job all done. And we'll finish off with one more exercise. Okay, last exercise. Ready function void del car, so we're going to steal that because we're going to need it. That transforms the word by deleting all instances of the letter from it. For instance, del car of aardvark in the letter A would change the word to rdvrk by removing all the A's. So let's give this a shot. We're going to need a function here. It's called del car. And our goal here is to go through the word, and we're going to need to remove all the characters that match the letter. So first half, we need to go through this. Now you could use a for loop, but here's the trick of using the for loop. As one way that we can, I guess there's a couple ways we can do this actually. Let me go through both just for fun. So we'll take the simple approach first, and then we'll do the trickier one after. So the simple approach is actually, we're going to make a second word. Or actually, does this work? Oh, right, this is void, so we can't return a new, the thing I was thinking of doing is maybe if we made a new string and returned that. I guess one thing you could do is build a new string, reassign the word to the new string, but I think we want to actually use our string methods. And in this case, we want to transform this word by deleting the characters. So to do that, we're going to have to do the slightly trickier way of doing things, which is we're going to do, and we're going to have a loop that goes until we reach the end of the word. So we're going to need to index through our word. So index, we'll start at 0. And as long as index is less than the length of the word dot length, we're going to keep going. While, yes. Okay. So, while we have not reached the end of the word, we're going to need to go through each character and check, is this a character we need to get rid of? So, if word at the index is the character we need to get rid of, then we need to get rid of that character. The way we can do so is word.erase. I'm going to erase the character at the index. If it is not the character we need to erase, then we just need to progress through the word, move on to the next letter. So otherwise, we're going to increase our index. Now, if this happens, we're going to progress through the word and get one step closer to reaching the end. And if this happens, the word will get shorter. So in either case, we're always going to have ourselves moving one step closer to finishing our function. And at the end of it, let's print it out to see if it works. So comment all this out, and let's try out our del char. So our word that we're going to practice with is, we'll try aardvark. And our letter is going to be A. We're going to delete the word and the letter, and we're going to print it out. The new word is word. Let's try it out and see what happens. It didn't seem to work, so perhaps our issue is with erase. Now, let's look at our slides just to see if there's something that I missed here. Okay, deletes length letters starting from the index in the string. Okay, so I've used the wrong format for our erase. What we're looking to do here is we need to specify the first index and how many characters we're getting rid of. In this case, we just need to get rid of one character at a time. So in our erase here, we're looking to delete one character, which should get rid of what we're looking for. Okay, let's try that again. That also did not seem to work. Interesting. So let's see why that is the case. Perhaps to show that this is working, let's try printing out the word every time we go through our loop here, just to see what happens. Interesting. So what seems to be happening here is that in our code, we are correctly getting to our aardvark, but it doesn't seem like the modifications to our word are actually taking place. And the most likely reason for this is that it's passing by value. So instead of passing the word aardvark that we want to work with, we're passing a copy of the word aardvark, which is not actually getting modified like we want. So to fix that, we're going to add an ampersand right here. Let's try it again. And look at that. Now it's actually giving us the right word. So we can delete this little line of code I added to fix things here, and let's double check with something else. Let's have a good long word. Supercalifragilisticexpialidocious. I probably spelled that wrong, but hopefully I'm not more than a few letters off. And I noticed that there are a lot of I's. So let's try to get rid of them and see what happens. And look at that, the new word is the same word, but there are no I's in it. So we got it. Looks like everything is all good to go. So that is all of our string exercises for today, and I will see you in the next video. Bye, guys.